Welcome to a quantitative aptitude video on mixture and alligation from careerright.com. This is one of the most important and most feared topic in quantitative aptitude, and hence every placement test, job interview, bank MBA and other exams have at least 2 to 3 sums on mixtures. Today in this video, we'll see shortcuts and tricks to quickly and easily solve all sums related to mixtures and alligations. Practice questions are there on careerright.com, which has practice test as well as 1000 plus aptitude questions. So now, mixture and alligation. Before starting with sums of mixture and alligation, it is very important to understand two small tricks which are very useful to solve all the sums related to mixture and alligation. We must understand that most of the sums of mixture and alligation could be solved very easily using common sense and simple logic. But these two tricks are extremely useful, and it is much better to know what they are right now so that it would be very helpful to solve the sums. Let us see the first trick. Now, what generally is given in a mixture sum? You'll be given two quantities, or what we can say two objects, like say wheat and rice. Okay. Now price for both these would be given. Okay. Price for both these would be given, and what they'll ask you is that when we mix these two quantities, okay, in some proportion, you'll get a third quantity or a mixture, right? You'll get a mixture. And in what ratio have we mixed these two quantities so that the price of the mixture is, say, something like X, Y, Z. Let us take an example. Let us say that rice is 80 rupees per kg. Okay, 80 rupees per kg. Wheat is 60 rupees per kg. Wheat and rice are mixed in some proportion, and the mixture which we get after mixing wheat and rice, it is, say, 75 rupees per kg. Okay. So what they are asking right now is that in what quantity have we mixed wheat and rice? How to calculate that? Take a look over here, pay attention very closely. It is very easy if you pay attention. Okay, see, now we have wheat and rice. Out of that, rice is costlier than wheat, okay, because rice is 80 rupees and wheat is just 60 rupees. So we have a cheap quantity, okay, and then we have a costly quantity. Right? What is the costly quantity? Rice. What is its rate? 80 rupees per kg. What is the rate of wheat? 60 rupees per kg. This is nothing but the price. Okay. This is the cheap one. This is the costly one. Now, but obvious, whenever we mix these, whatever mixture we'll get, the price of the mixture would be in between 60 and 80. So, at the center, here I'll write the average price of the mixture, or the average. Okay. Average of these two quantities, when we mix, what would the average price be? They have given the price of mixture is 75 rupees. Okay. Now we have three quantities. We have the cheap one, we have the costly one, and we have an average. Now what do we want? We want the ratio of quantities, right? We want the ratio of quantities of wheat and rice. What is this? This is wheat, the cheap quantity. This is rice, the costlier quantity. Okay. Now, what to do? Very easy. Costly means 80, average is 75. 80 is greater than 75, subtract. Okay, 80 minus 75, what do you get? 5, right? Again, average is 75, cheap is 60. Subtract. 60 minus 75, you will get negative answer. So don't do that way. What you will do? 75 minus 60. 75 minus 60. What is the answer that you will get? 15. 5:15 is the answer. The ratio of quantities of wheat to rice has to be 5:15. This is the answer. See how easily we got the answer. Now this is not the actual weight. That is, we are not saying that add 5 kg of wheat and take 15 kg of rice or anything like that. We are just saying whatever wheat and rice you take, it should be in the ratio 5:15 in the mixture, right? So this is nothing but ratio of quantities. If you remember this trick, that write the cheap one on the left hand side, write the costlier one on the right hand side. You can even reverse it. You can have costlier over here and you have cheap over here, and you will have the average in the between. So costly minus average would give you one value, average minus cheap would give you one value, okay, and that would be just the ratio. Price has to be written over here, ratio of quantities would be obtained at here in the bottom. Just remember this trick, this would make life very easy and help you solve mixture problems very fast. Now apart from this, there is one very small concept. Let's take a look at it, okay. Now say this is a container and it has a mixture. It has a mixture of wine and water, okay. Now let the mixture be of 160 liters. Total mixture is 160 liters, okay. Now what have they given? That ratio of wine and water or wine to water in the mixture is say 5:3, okay. What does that mean? That means that in the mixture there are 3 parts of water and 5 parts of wine. Is that right? So if we want to just express how much is the wine, okay, what you will write? You will write wine is nothing but 5 parts in the mixture, okay. Now 5 parts of what? 5 parts of 5 plus 3, that is 5, total liquid is 8 parts, because in the entire mixture there are 3 parts of water, 5 parts of wine. So water plus wine, 5 parts plus 3 parts would give us 8 parts. So there is 8 parts liquid, and in that 8 parts liquid, that is 8 parts of mixture, 5 parts are wine. And how much is water? Water would be 3 parts. We know that out of how much? Total 8 parts. Now if we divide this wine upon water, what you will get? Wine upon water, that would be equal to 5 upon 8, 3 upon 8, 8 gets cancelled, you get 5 upon 3, that is nothing but 5 by 3, which we started with. That is the ratio of wine and water. So whenever you have a mixture and if they have given the ratio of 2 quantities, one quantity can be expressed as very easily 5 upon 5 plus 3, that is nothing but 5 upon 8, that is 5 upon total amount of liquid which is there. Now can you you must have seen the videos related to partnership or videos related to ratio and proportion. This is similar to that. Whenever we are finding share of profit of A and B, okay, if it is A is to B, share of A would be how much? It would be A upon A plus B into total profit, right? Same way over here, amount of wine is 5 by 8 parts. Now if they have given that the total mixture is 160 liters, then we can find the amount of wine by 5 upon 5 by 3 multiplied by 160, right? 160 is the total mixture, right? If they are not given the total mixture, then also it is fine. We can simply say that amount of wine is 5 by 8, amount of water is 3 by 8, and when we mix both of these, we get the entire mixture, okay? Just remember these two concepts and this would help you to solve all sums related to mixture and alligation. Let's see question number 1. One can is completely filled and contains 100% water. Another similar can is completely filled with a solution of 50% wine and 50% water. When both the cans are emptied in a steel vessel, what will be ratio of water to wine in the vessel? This is very easy, we can solve by common logic. Let us see. Now they are saying that there are 2 cans and both are similar. That means both have the same capacity, right? So let us assume that can 1, okay, has capacity of 100 liters and it is completely filled and has 100% water. So can 1 will be having 100 liters of water, okay. Now can 2 is also of 100 liters, but it has 50% wine and 50% water. So it will have 50 liters of wine plus 50 liters of water, okay. Now both of them are emptied in a steel vessel. Now how much would be the amount of wine in this vessel? It would be 50 liters, because here there is no wine. This 50 liters would get added. So wine is 50 liters, okay. How much is the water? This 100 liters plus this 50 liters, 150 liters of water. What do we want? Ratio of water to wine in the vessel, that would be nothing but 150 liters to 50 liters, that would be 3:1. See how easily we got the answer. Moving to question number 2. Resultant price of mixture of golden rice is rupees 480 per kg. This mixture is made up from two varieties of golden rice which are having price rupees 420 per kg, rupees 520 per kg. What should be the ratio of quantities of both types of golden rice? Now again easy, we just have to use our trick, the cheap quantity, the costly quantity, the average one, subtract, and here also subtract, and we get the ratio. Okay, now let us see. There is a mixture of golden rice and the price of that rice is 480 per kg. Okay, now it is made up of two varieties of rice. One is cheap one, 420 per kg is the rate, other is costlier one, 520 per kg is the rate. So we'll have the cheap quantity, we'll have the costly quantity of rice. Okay, cheap quantity rate is rupees 420 per kg, costly quantity rate is rupees 520 per kg. The average or the mixture, okay, average has the rate as rupees 480 per kg, right? This is nothing but the price. So what we will get over here? We will get over here ratio of quantities. Okay, now let us see what is the ratio of quantities of the cheap to the costly golden rice. Subtract 520 minus 480, what do we get? We will have 520 minus 480, 40. Okay, over here 480 is greater than 420, so 480 minus 420 we will have 60. Ratio is 40 is to 60. Okay, that is nothing but 4 is to 6, that is 2 is to 3. So both the quantities have to be mixed in the ratio 2 is to 3, right? So this is the cheap quantity, cheap golden rice quantity ratio, and this is the costly golden rice quantity ratio, right? See how easily using this trick we were able to solve this sum. Just remember this, you will be able to solve most of the sums using this trick. Now moving to next question. Question number 3. A mixture consists of some amount of sandalwood oil and 240 liters of water. It is priced at rupees 275 per liter. Sandalwood oil is priced rupees 325 per liter. How much oil is there in the mixture? Again, it is a very easy sum. We have to use the same technique and same trick which we have learned. Okay, what do we have over here? We should have a cheap quantity and we should have a costly quantity, right? Cheap quantity over here is nothing but water. Okay, always remember here price of water is not given, but whenever there is water and if they have not given the price, always take price of water as 0 rupees, right? It is the cheap quantity. Now sandalwood oil is the costly quantity, price of it is 325 rupees per liter, right? So here we will be having price and here we will be having the ratio of quantities, right? Quantity of water is to oil, right? Ratio of quantities. And since cheap, costly, you will have the average object or the mixture, price of mixture over here. What is the price of mixture? 275. Okay, let's calculate. You will have 325 minus 275 as 50, 275 minus 0 as 275. So the ratio is 50 is to 275. Divide by 25, you will get 2 is to 11. This is the ratio of water is to oil, right? So water upon oil is nothing but 2 upon 11. But we already know that the amount of water in the mixture is 240 liters. So what we will get? 240 liters divided by amount of oil would be equal to 2 upon 11. This comes out to 120. The amount of oil will be 11 into 120, that is 1320 liters. Okay, see how easily we got the answer. Moving to question number 4. How much milk should be added in milk solution to make milk quantity in it 75% if 80 liters of the milk solution has 45% milk in it? Now directly by observation we can see it is related to percentages and it is very easy. So we might not need the formula, but let's try to solve it first by logic, and if we are not able to solve it, we'll try it with the formula. Okay, now what have they given? First, there is 80 liters of milk solution and in it 45% is milk. Okay, so how much exactly is the amount of milk? 45%, that is nothing but 45 upon 100 of 80 liters. That would be, let us see, 45 into 2 is 90, 9 4s are 36, 360 liters upon 10 would be 36 liters is the amount of milk in the solution, in 80 liter solution. Now what we want is that we add some amount of milk into this so that the total quantity of milk in the solution becomes 75%. Right now we have 80 liter solution. Okay, we are adding into it m liters of milk. Okay, let us assume m liters of milk. How much would be the final solution? 80 plus m liters. In 80 liters we have 36 liters of milk. Okay, 36 liters of milk. Now in 80 liters we are adding m liters of milk. That means the quantity of milk will be now 36L plus m liters. So quantity of milk is 36 plus m liters. Okay, this is liters. Now what have they given is that when we add some milk into it, how much milk we should add? When we add m liters of milk into it, milk quantity becomes 75%. So milk quantity we already know 36 plus m liters. It is nothing but 75% of the solution. What is the new solution amount? It is nothing but 80 plus m. 25 3s are, okay, 25 4s are, what we will have? 36 into 4 plus 4m would be equal to 240 plus 3m. So we will have m equal to 240 minus 144. That would be nothing but 240 10 minus 4 is 6, 96 liters. So 96 liters should be added so that the quantity of milk becomes 75%. See how easily we got the answer just by logic. We don't need to use any formula. Most of the sums you might be able to solve even by simple logic. Moving on to the next question. A pot contains 40 liters of juice. How much juice will be there in the pot if 4 liters of juice was removed and was replaced by water, and this process was again repeated twice? Now this looks a little bit tricky or complex or a puzzle type of sum, but actually it is very easy if you pay very close attention. Okay, if you pay very close attention, you will understand it at the first attempt only. You won't have to think over it more. It is very easy. There is no formula involved over here, just small concept which we have learned at the start, right? So let us see how to solve this sum. Okay, now first there is a pot and it has 40 liter of juice. Okay, how much water is there? 0 liters, right? 0 liter water. Now they remove 4 liter of juice. 4 liter juice is removed. On removing 4 liter of juice, how much juice is left? 36 liters, right? Now the pot has 36 liters of juice, and what they have done, after removing 4 liter of juice, they will add 4 liter of water. Corresponding amount of water is added. So how much water is there now in the pot? 4 liter water is there. So what is the ratio of juice to water? It is equal to 36 is to 4. 36 liter is to 4 liter. Okay, we will not reduce it, we will keep it as it is, right? Now what is the total mixture amount? It is nothing but 40 liters is the total, right? Total is 40 liters. It remains the same because we are removing 4 liters, adding 4 liters. So total remains the same, right? 40 liters. So what is the actual quantity of juice right now? The actual quantity of juice is 36 liters. Total is 40 liters. When we removed 4 liter of juice, okay, we got 36 liter of juice. Now again, this process was repeated twice, they say. This is once, right? Once already over. After this again twice it was repeated. So total it will happen for 3 times. So one time it is over. Now second time again they remove 4 liter of the mixture. Now they don't remove 4 liter of juice, they remove 4 liter of mixture, because once you mix juice and water, it is very difficult to understand what exactly is juice, what is water. So what they do is they remove 4 liter of the mixture directly. So when they remove 4 liter of mixture, right, how much amount of juice has been removed from this? Now see, if a mixture has 36:4 amount of juice and water, then whatever mixture, if you remove some quantity of mixture, in that also juice and water will be in the same ratio. This is a very important concept. Say if a container has water and say oil and water in the ratio 2:3, and if you remove some of the mixture, then again the mixture which was removed will have the same proportion of oil and water. So this 4 liter mixture has juice to water ratio of 36:4, right? Same ratio, no difference. So how much is the amount of juice in this 4 liter? Let us see how to find out what is the share of juice. What is the ratio of juice? 36 divided by 36 plus 4, that would be, and multiplied by total amount of mixture that was removed, that is nothing but 4 liters. What do we get? 36 upon 40 multiplied by 4, 3.6 liters of juice was removed. If 3.6 liter was juice, water was 0.4 liters, correct? So juice removed right now was 3.6 liters. Initially 40 liter juice was there, then you removed 4 liter juice and you got 36 liter juice. After that you removed 4 liter mixture. In that mixture 36 liter juice was there. So now how much is the amount of juice left? 36 liter minus 3.6 liter, that is 32.4 liter juice has been left in the pot. Okay, 32.4 liter juice. Now after that, again this was repeated third time, 4 liter mixture removed. Okay, now after the second time, amount of juice, okay, became how much? 32.4 liters. Amount of water became how much? Rest is the water, right? What is the rest of the water? There is no need to calculate actually the amount of water, but still we'll say it is 7.6 liters. Why 7.6 liters? Because total amount of juice plus total amount of water is equal to 40 liters. Total is 40 liters. So if 32.4 liter is juice, 7.6 liter is water, right? Now after the third time, when 4 liter mixture was removed, right? When 4 liter mixture was removed, in this the juice and water will be in what ratio? It won't be in 36:4. No, it would be in this ratio, because initial mixture over here was having 32.4 liter juice and 7.6 liter water. So this 4 liter mixture which you removed, that too will have 32.4 liter, 32.4 is to 7.6 as the ratio of juice and water. Then what will be the amount of juice removed? Easily it would be, what is the ratio for juice? 32.4 divided by 32.4 plus 7.6 multiplied by how much mixture was removed? 4 liter. We have to find out how much juice was removed from 4 liter. So we take 4 over here. What you will get? You will get 32.4 multiplied by 4 divided by 40. That would be 10. Okay, that would, J would be nothing but 3.24 liters was removed from juice. Okay, so initially it was 32.4 liters. Now 3.24 has been removed. So how much juice is left? Let us see over here. It is 32.4 minus 3.24. Okay, what you will get over here? 10 minus 4 is 6, 3 minus 2 is 1. Okay, over here we will have 12 minus 3 is 9, 29.16 liter of juice is still left, right? So 29.16 liter of juice is left. Initially it was 40 liters, then we removed 4 liters at start, so we got 36 liter juice. Then we removed 4 liter mixture. In that mixture, in that 4 liter, the juice was 3.6 liters, water was 0.4 liters. Okay, then we removed 3.6 liters. So how much juice would be left? 32.4 liter. In this mixture, okay, total was 40 liter mixture. In that 32.4 liter was juice. Out of that again we removed 4 liter mixture. Okay, out of that 40 liters. So that 4 liter had 3.24 liter juice. So now the final quantity of juice left was 32.40 minus 3.24, that is 29.16 liters. Generally what happens is that, what mistake do people do? They consider, okay, 40 liter juice was there. First I'll remove 4 liters. I'll get 36 liter juice. Then I'll add water. Okay. So I'll get 40. Again I'll remove 4 liter juice. I'll get 32 liters. Again I'll remove 4 liter juice. I'll get 28 liters. And they write the answer as 28 liters. This is wrong. The answer is 29.6. You saw that whenever we remove the mixture, some part of the mixture will be juice and some part will be water. Okay. Moving to next question. Question number 6. One glass has juice and water in the ratio 5:2. while other glass has them in the ratio 7:4 respectively. If both glasses poured in a vessel, then what will be final ratio of water to juice in the vessel? Now over here again very easy this sum, okay, we can solve it with logic, we might not need the formula also, right? When do we use formula and when do we use logic? Now in formula what we have the price and we have the ratio of quantities, that is in what quantity we have to mix them. Now even if there is no price, if there is some other quantity, generally here we get the ratio of quantities in which we have to mix, right? So whenever we have to find ratio of quantities in which we have to mix two objects 1 and 2, then only we can directly use the formula. Rest we can solve by normal logic. Let us see what logic we have to use. Now over here this is the first glass, okay, it has juice to water ratio of 5:2, okay. Now so how much is the amount of juice in this glass? Amount of juice is 5 upon 5 plus 2, is that right? That is 5 upon 7, right? 5 parts is juice in the entire mixture, 5 parts is juice, 2 parts is water, that means total the mixture has 7 parts. So out of 7 parts, 5 parts is juice. So what will be amount of water? 2 parts, correct? Second glass, juice to water ratio is how much? It is 7:4, right? Out of that juice is 7 parts, out of 7 plus 4 is 11. Water is how much? 4 parts out of 11, is that right? Now when we mix these two quantities, okay, in the vessel, okay, in the vessel when we mix these, okay, juice, what will happen? Juice from here and water from here, that is the first glass, will get mixed with juice from the second glass and water from second glass. So when we mix it in vessel, we will have juice and we will have water again, okay, total, right? What will be the amount of juice in the vessel? It would simply be 5 upon 7 of the first vessel plus 7 upon 11 of the second vessel. What is that? 77. 7 into 11 is 77. 5 into 11 is 55. 7 into 7 is 49. What we will get? 55 plus 45 is 100. 104 upon 77. This is the amount of juice, okay, or the quantity of juice. This is not in liters or anything like that. It is just calculation of a ratio. Now secondly, in the vessel how much will be the water? Water from first glass plus water from second glass, that would be 77, 22 plus 4 sevens are 28, 50 upon 77. What do we want in the final vessel? What will be the final ratio of water to juice? Amount of water 50 by 7, juice 104 by 77, okay, this gets cancelled, okay, this is water is to juice. What you will get over here? When we divide by 2, you will get 25:52. This is the final ratio of water to juice in the vessel, okay. Moving to next question. Question number 7. Ramesh mixes 60 liters of type 1 acid with some liters of type 2 acid. Type 1 acid rate is rupees 32 per liter, type 2 acid rate is rupees 23 per liter. Ramesh sells this acid mix at rate of rupees 28 per liter. How much type 2 acid is needed to make it a no profit, no loss transaction? Now, over here we can definitely use the formula or the trick which we have seen. What is it? The cheap and the costly trick, okay? But you already know this trick. Let us solve this sum in a different way using simple logic. Say if you forget the formula or the trick in exam, let us see how can we solve this sum using normal logic. Now what does Ramesh do? He takes type 1 acid and type 2 acid, okay. How many liters of type 1? 60 liters. How many liters of type 2? We do not know. Let us assume type 2 acid is of say S liters, okay, S liters. What is the rate of type 1? It is 32 rupees per liter, okay. Type 2 rate is rupees 23 per liter. How much is the cost, total cost? 60 into 32, okay. This is S into 23, okay. This is for type 1 cost, this is type 2 cost, okay. This is the total cost which Ramesh incurs. He mixes these both and he sells the mixture, okay, to whom? To outside at the rate of 28 rupees per liter, okay. How much liter mixture will be? 60 plus S, okay. When we mix both the mixtures, okay, when we mix both the types of acids, the total acid which Ramesh will get is 60 liters plus S liters. That is the total amount of acid in liters. Okay, this is liters, and rate of this mixture is rupees 28 per liter. So total amount which he'll get is rupees 28 into 60 plus S. Now why do we put an equal to sign? Because they have said that he should have no profit and no loss. That means whatever is his cost price, okay, whatever he spends would be same as whatever he earns, right? So he is spending this much money to get these acids and mixing them, and he is earning this much money, which both are equal. Let us see what the answer is. This is 60 into 32 plus 23S would be equal to how much? Again, let's write it over here. Into 32 plus 23S would be equal to 28 into 60 plus 28S. No need to calculate this. What you can do is you can take it over here, take 60 common, 32 minus 28, how much it is? 4. That would be equal to 28 minus 23, how much? 5S. Okay, therefore S would be equal to 5 into 12 4s are 48. So 48 liters of type 2 acid is needed by Ramesh to make it a no profit no loss transaction. See, without using formula, even by logic, we solved the sum. Going to question number 8. In a mixture of 90 liter, the ratio of acid and water is 2:1. If the ratio of acid and water is to be 1:2, then amount of water in liters to be added to the mixture is, again, pretty easy. Okay, we can use logic over here, no need to go to formula or anything else. What have they given? Mixture is 90 liters in total. Okay, 90 liters is the mixture. In that, acid to water ratio is 2:1. Okay, now we have to make the ratio 1:2, right? Right now we have to find out how much amount of water is to be added. Initially, how much water is there? Share of water is how much? Ratio of water is 1 divided by 2 plus 1 into total mixture is 90 liters. That comes out to be 30 liters of water. Okay, so how much is the acid? Acid is 90 liters minus 30 liters, 60 liters, right? 60 liters. Now, what do we have? We have 30 liters of water, we have 60 liters of acid. Now, the ratio initially is 2:1. We have to make the ratio 1:2. That means acid to water ratio has to be 1:2. That means if one part is acid, 2 parts are water. So if 60 liters is the acid, how much should the water be? Twice of that, that is 120 liters. Right now we have only 30 liters water. We have to make it 120 liters. How to make it 120 liters? Just add 90 liter more water, right? 90 liters of water. When we add into this, 90 plus 30 is 120. Okay, when we add 90 liters of water, we will get 120 of liters of water, and the acid would be 60 liters. So the ratio automatically would become 1:2. So our answer is 90 liters water. Moving to next question. Question number 9. 3 types of sugar got mixed by accident in a shop. First was of the rate rupees 145 per kg. Second was of rate rupees 165 per kg. Only thing the shop owner knew that quantities of 3 sugar types were in the ratio 2:1:3 respectively. He finally sold the mix at the rate of rupees 180 per kg. What was the price of the third type? Again, extremely easy. Generally we have seen that formula is cheap and costly. Okay, only 2 of the objects are there, but here there are 3 objects or 3 types of sugar. So we don't need the formula. Actually very easily using ratio and proportion or common sense we can solve this sum. Let us see how. There are 3 types of sugar. First type, second type, third type. Okay, rate of first is 145 rupees per kg, second one is 165 rupees per kg, third one is we do not know, that we have to find out, right? How much quantity of the, and then there is the average mixture. Okay, rupees 180 is the rate, okay, at which he sold it. Now the first quantity, what is the quantity of the sugar of the first type? We do not know. They have only given the ratio 2:1:3. So this is the ratio of quantities. Now we do not know the actual value. Just like in ratio and proportion, we have learned that whenever ratio is given and we have to find actual value, first start with assuming the common factor as k. So the actual value would be 2 into k is 2k, 1 into k is 1k, 3 into k is 3k. So first type of sugar, quantity of first type of sugar is 2k kg, second type it is k kg, third type it is 3k kg, and when the three of them mix, okay, how much would be the final mixture quantity? It would be 2k plus k plus 3k, that is 6k kg, right? Now he sold the mix at the rate of rupees 180 per kg. They have not given if there is profit or loss or anything like that. In such cases, we should remember that if they have not given any profit or loss or anything like that, we should always take this transaction as no profit, no loss. Okay, that means equal. So whatever would be the price of these would be equal to the, whatever would be the price of these would be equal to the price of this, right? That means whatever he spends on buying this, that would be the same amount he earns over here. So how much does he spend over here? 145 rupees per kg into 2 kg. Okay, this is for the first type, plus 165 rupees per kg into k kg. This is for the second type, question mark into 3 kg. This is for the third type, would be equal to 180 rupees per kg for 6k kg. Okay, this is 3k kg. Now k gets cancelled everywhere, right? What do we have over here? 145 into 2 is 145 into 2 is, say, what will be 280, 290 plus 165 plus 3 into question mark would be equal to 180 into 6. 180 into 5 is 90. 90 plus 90 plus 18 is 1080. So we will have 1080 over here. So 3 into question mark would be 1080 minus 290 minus 165. What would that be? 1080 minus 290. Let's add this. We will get 5, 5, 3, 4, 5. That would be 10 minus 5 is 5, 7 minus 5 is 2, again 10 minus 5 is 5, 525. So let's solve. Question mark would be 525 by 3. 3 ones are 22, 7s are 15. 175 rupees is the rate of the third type. See how easily we got the answer using simple logic. Moving to the next question. Question number 10. A mixture of two food items has a salt to sugar ratio of 7:32. The ratio of salt to sugar is 2:11 and 5:21 in the two individual types of food items. In what proportion are the two food items mixed? Now we have learned that whenever we have to find the ratio of quantity or the proportion of mixture, we generally use the formula. What is the formula? We have the cheap, we have the costly quantity, we have the average, and then we get the ratio of quantities. Okay, but the problem over here is that generally what we have while using the formula, we have two quantities or two types. Okay, now over here, and they have their own price, and then we find the quantity. But over here the problem is there are two types of food items, and each food item has two types of quantities. One is salt and one is sugar, right? So which one to take cheaper, which one to take costlier? Now this becomes difficult, but actually it is not. We have to use the same technique. Okay, it is very easy, and it will become clear to you in a minute while solving the sum how to approach these kinds of sums when each type has individual elements also to it. Now say this is a mixture. It has salt, okay, and sugar. This is then there is another mixture. This also has salt and sugar. Okay, salt and sugar. Whenever we mix these two, this amount of salt over here will also get mixed, and amount of sugar will also get mixed, right? So even if we consider salt and find the values, still we'll be able to, from this we'll be able to find the values of sugar or the values of total mixture. Same way, even if we consider just one quantity sugar, we'll easily be able to find the amount of salt, right? So now what we have to find out first is that which one to take. Now you can take salt or sugar, anything is fine. Let us assume salt. Let us solve using salt as our quantity. Okay, now there are two types, right? This is type 1, this is type 2. Okay, these are two type of food items. So we'll have cheap and costly, we'll not consider over here. We'll just have type 1, type 2. Then we have the mixture. Okay, right? Now in type 1 and type 2, what quantity, what do we have? We generally initially we used to have the price and ratio of quantities, right? Now instead of price, what you will take? amount of salt you will take over here, right? You can take sugar also, anything is fine, you will get the same answer, but let us go with salt. Now, what to do? First, what is the amount of salt in type 1? They have given for type 1, the ratio of salt, okay, salt to sugar is 2:11. That means 2 parts salt, 11 parts sugar. What does that mean? 2 plus 11, there are total 13 parts of type 1 food. In that 2 parts are salt, 11 parts are sugar. That is 2 parts are salt out of total 13 parts, right? Same way in type 2, 5:21, salt to sugar ratio. So 5 parts are salt in total of 5 plus 21, 26 parts of the food item, right? In the mixture, salt to sugar ratio is 7:32. That means 7 parts are salt of the total 39 parts of the mixture, okay? Now we have to find out what ratio of quantities, that means ratio of proportion in which these two types of foods are mixed. How to do it? We have always seen, what we do, we take costly, look at the right hand side, we take costly minus average, okay, and then we take average minus the cheap one. But here we do not know which is greater, which is less, so subtract any by any way, and if you get a minus sign, just neglect it. So let us say we subtract like this, okay, 5 by 26 minus 7 by 39. What do we get? 5 by 26 minus 7 by 39, okay. What you will get over here? The LCM over here would be nothing but 26. Everything is divisible by 13 over here. So this is 2, this is 3. Let us take the LCM as 26 into 39. So what you will have over here? 5 into 39 minus 26 into 7. What you will get? 26 into 39, okay. So take 13 common from here. What you will get? 13 is 5. 13 into 3 is 39. 5 3s are 15. 13 into 15 minus 13 2s are 2 into 7 is 14. Okay, that would be 13 upon 26 into 39. 13 3s are, you will get 1 upon 878. Okay, 1 by 78 is over here. So you will have 1 by 78 over here. Now we have to find the second quantity. Simply subtract like this. What you will get? 2 by 13 minus 7 by 39. Okay, 39 is the LCM over here. So we will have 2 into 3. Okay, 6 minus 7, that would be minus 1 by 39. Neglect the minus sign. Answer is 1 by 39. So here we will get 1 by 39. So what is the ratio of quantities of type 1, okay, to type 2? What it will be? 1 upon 78 is to 1 upon 39. Now we know 39 into 2 is 78. So let us multiply throughout by 78. What you will get? 78 upon 78, 1. Okay, 78 upon 39 is 2. So type 1 to type 2 must be mixed in the proportion 1:2. See how easily we got the answer. Instead of salt over here, you can anytime take sugar also. You will get the same answer, 1:2. Moving on. Question number 11. A solution of honey and water is 28 liters with honey and water in the ratio 4:3. To this, a 21 liter honey water solution is added that has honey to water ratio as 2:1. Again, a 51 liter honey water solution that has honey to water ratio of 9:8 is added to this. After this, 10 liter of the solution is replaced with pure honey. What is the ratio of water to honey in the final mixture? Now this is a very lengthy and long sum, okay, but solution is very short, very easy and very short. You might look at this and say this is very big, how to solve this? But again, simple logic will come to help and we will be able to solve this sum. Let us see how. First, we have 28 liters of mixture. It is a mixture of what? Honey and water. In that, honey and water is in the ratio H:W is what? 4:3, right? Now that means 4 parts honey, 3 parts water. So total parts are how much? 4 plus 3, 7 parts of the mixture are there, and out of those 7 parts, 4 parts is honey, 3 parts is water. So how much is honey actually? 4 parts of honey out of 7, into total amount of mixture, that would be 16 liters. So in 28 liters of the mixture, 16 liters is honey. How much is water? 28 minus 16, 12 liters, right? Now to this 21 liters of the mixture is added of honey is to water having the ratio 2:1, right? How much is the honey in this 21 liter? Simply ratio of honey is to 2 plus 1 multiplied by 21, 14 liters. How much is the water? 21 minus 14, 7 liters, right? Now again 51 liter of the mixture is added to it having honey to water ratio of 9:8. Okay, how much is the honey in this mixture? 9 upon 9 plus 8 is 17 into 51. So 9 3s are 27 liter is the honey. How much is the water? It would be 24 liters. Okay, after this, how much is the total honey in the mixture now? We have mixed all these three, right? So total mixture, first of all we will find out. Total mixture is how much? It is 28 plus 21 plus 51. What we will have? 8, 9, 10. 2 is 4, 5, 100 liters is the total mixture. Now how much is the total honey? It would be 16 liters plus 14 liters plus 27 liters, that comes out to be 57 liters. How much is the total water? 12 liters plus 7 liters plus 24 liters, that comes out to be 43 liters, or you can simply say 100 liters minus total amount of honey, that is 57, you will get 43 liters of water. So in the mixture of 100 liters, what is the ratio of honey is to water? 57:43. Just remember this. Okay, now what they do, they remove 10 liter of this mixture. So they remove 10 liter from this 100 liters. Okay, we have learnt that whenever we remove something from the mixture or some amount from the mixture, the amount which is removed, it will have the same ratio of the content. So honey is to water ratio will be the same in this 10 liter as the 100 liter. So what is the honey is to water ratio in this 10 liter? 57:43. We have found out over here, right? So in this 10 liter, how much is the honey? It is simply H would be equal to 57 is the ratio of honey divided by 57 plus 43 is 100 into 10, that would be equal to 5.7 liter is honey. If 5.7 liter is honey, how much is water? Okay, water would be 10 liter minus 5.7, 4.3 liters. So this much is the amount of water and this much is the amount of honey in the 10 liters. So initially in the 100 liters we had 57 liter of honey. Out of that we removed 10 liter mixture. So because of that 5.7 liter of honey was removed. And what they said was that this 10 liter which was removed, this 10 liter solution which was removed, it was replaced by pure honey. So they added 10 liter honey. How much is the total honey now? That would be equal to 61.3 liters. Okay. Now, how much is the amount of water? Initially we had 43 liters. Then we removed the 10 liter solution. That means in that 10 liter solution we had 4.3 liters of water. So 4.3 liter water was removed. Okay. And no water was added, only honey was added. So we stop over here and the subtraction comes out to be 38.7 liters, right? So what is the ratio of honey is to water now? It is 61.3 is to 38.7, which can also be written as 613 is to 687. Okay, so this is the answer, that is the final ratio of water to honey in the final mixture. See how easy it was. You might think that this question is lengthy, answer is lengthy, but in exam actually you will be able to solve this in hardly 1 minute. Why? Because you will be practicing mixtures and immediately you will understand, okay, we have to find amount of honey, we just add it, find the ratio, just check out how much honey is removed, how much water is removed, and we will get the ratio. You will be easily be able to solve this sum in 1 minute in exam if you practice little bit, right? See how easy and short the solution was. Moving to the next question. Question number 12. Rohit buys some rice at rupees 10.40 per kg. He mixes it with some rice having price rupees 8.8 per kg. The final mixture becomes 15 kg in weight and with total worth rupees 146.40. What is the quantity of rice priced at rupees 8.8 per kg? Again, now we have to find the quantity of rice priced at the lower, that is the cheaper quantity. So what do we use? The formula. Very easily, we have two quantities, cheap rice and the costlier rice. We have the average price. What do we do over here? Let us start with cheap rice and costly rice. Price of the cheap rice is what? 8.8 per kg. Costly is 10.40 per kg. Okay, we want the ratio of quantities that would come over here. The average or the mixture price, we do not know the rate, but what do we know? Total price is 146.40. Total price or the total worth is 146.40 divided by total amount is 15 kg. That would be nothing but rupees 9.6, right? So rate of the mixture is 9.6. So what do we get over here? 10.40 minus 9.6 is 0.64, okay, and 9.6 minus 8.8 is nothing but 0.96. Ratio is 64:96. So 32 2s are 32 3s are. So ratio of the cheaper rice to the costlier rice is 2:3, right? Now what they have given is that total. Now we know only the ratio of both the type of rice. We do not know actually how much is the amount. How to find the actual amount? Assume the common factor to be k. So the actual amount is 2k kg and 3k kg. And we already know that the mixture which is there, final mixture is there, it is of 15 kg. So addition of this would be 15 kg, k would be equal to 3, okay. So over here we have the cheaper rice is 8.8 rupees per kg and its quantity is nothing but 2 or 2k. So quantity of it would be 2 into 3, it is 6 kg. So 6 kg is the quantity of rice priced at rupees 8.8 per kg, which is mixed with the other one. Moving to question number 13. Sunil started a juice, that is lemon syrup plus water counter. Initially he had 140 liter juice which had 30% water in it. He sold 20 liters of the juice. Then he added equal amount of lemon syrup and water. Now the ratio of water to lemon syrup became 1:2. How much water was added later on? Okay, now again this is very easy sum and we can solve it by logic. Let us see how to solve it by logic, by common sense. He had 140 liters of juice. Okay, juice is nothing but lemon syrup, pure lemon syrup and water. Out of that 30% is water. So how much is the lemon syrup? Common sense, it is 70% is the syrup. Okay, syrup is 70%. So in the entire mixture 30% is water, 70% is syrup, right? Out of that he sold 20 liters. Okay, he sold 20 liters. So how much is remaining? 120 liter remains. Even in this 120 liters there is 30% water and 70% syrup, right? There is 30% water and 70% syrup. So how much actual water is there? 30% of 120. What it would be? You will get it as 36 liters of water is there, right? If 36 liters of water is there, how much is the syrup? You can find it by 70% of 120, or we can simply do 120 minus 36, 84 liter of syrup is there. In this 120 liter which Sunil has, he has that 120 liter has 36 liter water and 84 liter syrup. Now what he does is that he adds equal amount of lemon syrup and water. So that means that if he adds 10 liters of water, he has to add 10 liter of syrup. If he adds say 5 liters of syrup, he will have to add 5 liters of water. So let us assume that Sunil adds a liter of water and lemon syrup. Okay, a liter of water and a liter of lemon syrup. So how much would be the quantity of syrup now? It would be 84 plus a. What would be the quantity of water now? It would be 36 liters plus a, right? This would be the amount of syrup. This would be amount of water, 36 plus a liters. And what have they given? Ratio of water to lemon syrup becomes 1:2. So water to lemon syrup ratio becomes 1:2. So so we have 36 plus A divided by 84 plus A equal to 1/2, right? Let's solve it. What do you get? 72 plus 2A equal to 84 plus, this is 84 plus A, okay? 84 plus A. So what you will have? A would be equal to 84 minus 72, that would be 12 liters. So the amount of water which was added by Sunil was 12 liters, right? So he added 12 liters of water and 12 liters of lemon syrup later on. Moving to next question. Question number 14. A milkman had water and milk mixture in a can with water to milk ratio 5:7. He accidentally spills 9 liters of the mixture. He then fills the can with water equal in quantity to spilled mixture. This makes the water to milk ratio 9:7. How much milk did the can initially have? Now we do not know how much milk did the can initially have. So let us try to solve this by logic, because here we do not want the ratio of mixture or anything, right? We have to find how much milk did the can have. We just know that there was can and there was some mixture into it, okay? And this mixture was of water and milk, and the ratio of water to milk in the can was 5:7. Ratio was 5:7. It was not the quantities. These are not the actual quantities. So how to find the actual quantities? Let us assume the common factor to be K. Actual quantity would be 5K and 7K. This is the amount of water. This is the amount of milk initially. Okay. This is the amount of water and milk initially. So if we find the value of K, we can simply multiply it by 7 and we can get the amount of milk which the can had initially, right? Now what happens is that the milkman accidentally spilled 9 liters of the mixture. Now that means 9 liters of the mixture was removed. Okay, if 9 liters was removed, this 9 liter will also have water to milk ratio as the original mixture, that is nothing but 5:7. So how much amount of water is removed? It is simply given by 5 upon 5 plus 7 into, we have to find out how much amount of water is removed how much amount of water is removed when 9 liter is removed, that is how much amount of water is there in this 9 liters. So 9. So 5 upon 5 into 9, 7 5s are 12. That would be nothing but 3.75 liters. Okay, this much amount of water is removed. Then how much amount of milk gets removed? That means how much amount of milk is there in this 9 liter? It would be 7 upon 5 plus 7 into 9, that would come out to 5.25 liters. Okay, so this much amount of water and this much amount of milk gets removed when 9 liters of milk mixture spills, right? So what does the milkman do? 9 liters is spilt, so 9 liter is lost. So what he does is that he fills the same amount of water. That means if 9 liter solution is removed, he will fill 9 liter of water into it. Okay, so how much now is the final amount of water? Initially the amount of water was 5K, then out of that 3.75 liter gets spilt, okay, gets removed. Then he adds 9 liters of water. How much do we get? We get 5K plus 9 minus 3.75 is 5.25. This is the amount of water, right? 5.25 plus 3.75, 6 plus 3 is 9. Okay, so this is the amount of water. Now how much is the amount of milk in the can? Initially the amount of milk was 7K. Then 9 liter mixture got spilled. So in that 5.25 liter of the milk gets spilled or removed. No milk is added later on, only water is added. So how much we have? We have 7K minus 5.25 liter of milk. They have given that in the final mixture, whenever the milkman adds 9 liter water, ratio of water to milk becomes 9:7. Ratio of water to milk becomes 9 upon 7. So that is nothing but 5K plus 5.25 upon 7K minus 5.25 would be equal to 9 by 7. On solving, we will get the value of K as 3. If value of K is 3, what is the amount of milk initially? It is 7K, that is 7 threes are 21 liters. Okay, 21 liters is the amount of milk the can had initially. See how very easy sums related to mixture and alligation have become. We just need to use a simple logic which we learnt earlier and a simple trick of cheap and costly things which we learnt along with that logic. Using these 2 to 3 things, you will be able to solve almost all the sums, rather all the sums related to mixture and alligation. Most of the sums related to mixture and alligation are in close combination to ratio and proportion. So make sure you see the video of ratio and proportion, make it strong, practice on it so that it will become easier to handle mixture and alligation. This is it for mixture and alligation. Do share the video with friends and give it a like if you liked it. Leave your comments and suggestions for us. You can also request a video on topic of your choice. Do not forget to subscribe to our channel to stay updated about upcoming videos and tutorials.